Okay, so let's continue from where we left off in the previous lecture, which is seeing the double dumbbelled shape of d orbital. We have already discussed the x, y, y, z, x, z, x, y minus y square and z orbitals of d subshell, and out of which the first three are belongs to the non-axial set category and also called T2G. Okay, and second set is the remaining two, which is x, y minus y square and z square, belong to the axial set and also called EG. So let's actually start off with seeing the spectroscopic symbols. Okay, so spectroscopic symbols first would be the non-axial set, so non-axial set is first we have T2G. Okay, so which is nothing but they are actually between the axis, and second we have axial set, which are also called EG, and they are along the axis, or in other words we can say that they have rich electron density E minus small e minus electron density between the axis for T2G, and here we have for EG rich electron density along the axis. Okay, so now we'll be seeing nothing but the shape of xy, yz, xz, which is T2G, and then we'll be moving on seeing EG, the shape of EG d orbitals. Okay, so let's get started. So first we have the shape of xy, so this is dxy, so this is y-axis, this is x-axis, so this has electron density between the axis, so the shape would be something like this, which is positive, negative, positive, and rather this would be both positive and this would be negatives. Okay, so it has first two nodal planes, and which one it would be having planes as xz and yz. Okay, I hope you can imagine, as in both the planes would be orthogonal to the electron density which is in the xy plane. Okay, so if we pass a xz plane through it, I hope you can imagine that along y-axis and along xz there will be no electron density. Okay, so there will be two nodal planes, and it would be rather a G-rate because it has even number of nodal planes. Next, let us draw the shape of d yz. So this is y and this is z. Again, just draw it similar to dxy. So it would be same, but we are just renaming the axis as, instead of xy we are just naming them as yz. That's the only difference. Minus and minus here. So again they would be two nodal planes. Okay, and nodal planes would be similar to it had xz and yz. Here the orthogonal plane both y and z would be x, so the nodal plane would be xy and xz, and again it would be G-rate because the number of nodal planes are in even number, so it would be G-rate. Let's actually see another example where we have dxy rather dxz. So again doing the same, just rename the axis and just redraw the same structure we draw for previous ones. So it would be positives here and negative here. Okay, so again it would be having two nodal planes. They would be nothing but yz and xy. Okay, why? Because the orthogonal plane to x and y planes are y plane, sorry, x and z planes are would be y plane. So again it would be g rad. Okay, so next let us see the structure for xy, which is eg. So we have already discussed that for eg electron density would be along the axis, not between the axis. So along the axis would be something like this. So this would be the shape of dx square minus y square. Again it would be having how many number of nodal planes? Two nodal planes. How? So we can have two nodal planes inclined at 45 degree to each other. Okay, in the same plane, as we can have something like this is the nodal plane, this is the first nodal plane, and this is the second nodal plane. Okay, so inclined at 45 degree to each other, and again this would be g rad, as the number of nodal planes is even in this case. Then again let us see the structure of dz square, which is the last one. Okay, belonging to the T2G category, rather EG category, which is dz square. Again this is a z plane. Okay, this one, and it also has a ring across the two dumbbells. So this is the structure of dz square. Okay, and it has zero nodal plane, as no one or no plane is passing through the center, which has no electron density, because it will either intersect with any of the rings, either on the positive side or either on the left side or on the right side. Okay, so it would be again g rad, because number of nodal planes is even in number, or 0 is considered even. Okay, so please note here that the opposite lobes will have same sign of psi or wave function. So we can see here, here and here. Okay, so just writing it as a note that opposite lobes in case of d orbitals have same sign of psi. Okay, so With this, we come to the end of this lecture. In the next lecture, we will be seeing more on the shape of d orbital. Till then, good luck and goodbye.